Hello students, good morning. Welcome back in a class of engineering chemistry. I am Asha Pawar, working as an assistant professor at SNJB's Late Sau KBJ College of Engineering, Chandwad, Nasik. Student, in last session we learn polymer composites, their properties, application, types of fiber reinforced composites, etc. Today we will learn another new topic in the unit, that is the nano material. It is a part B. First of all, what are nanomaterials? Students, nanomaterials are nothing but the set of substances where at least one dimension is less than approximately 100 nanometer. Means nanomaterial is a material in which among from the three dimensions, at least one dimension of that particle size approximately 100 nanometer, less than 100 nanometer. So there are two important factors that affect the properties of nanomaterial, and the first property is increased relative surface area. Depending upon the surface area of the particle, always the properties of nanomaterial like electronic property, then magnetic property can be changes. That second factor is, or second property is, quantum effect. As the size of particle, nanomaterial particle increase or decrease, their different properties changes, as well as it shows the quantum effect. This factor can change or enhance the properties such as reactivity, strength, electrical characteristic, magnetic characteristic, etc. So the surface effect in detail we are going to study, that is, as a particle decrease in size, greater proportion of atom are found at the surface compared to the those inside. That is, if decrease the size of nanomaterial, greater proportion of atom are found on at the surface compared to the inside particle. For example, particle of size 30 nanometer, 10 nanometer and 3 nanometer considered here. Then those having the greater size, that particle only present 5% on the surface. Those having the particle size 10 nanometer, that is, as here size decreases, the percentage of atom increases on its surface. Then again it is a 3 nanometer, again size decreases, then around 50% of atom on its surface. That is, depending upon the size, this depending upon the size of nanomaterial, percentage of atom decreases or increases. That is, nanoparticle are more reactive than large particle. Means nanomaterial having the small size, that is less than 100 nanometer, that's why they are more reactive, because due to the small size, the more number of atom present on the surface, therefore reactivity is always and always higher, and most of the catalyst used as a nanoparticles. Then second, quantum effect. See, the quantum confinement effect can be observed once the diameter of particle is of the same magnitude as the wavelength of electron, means the wave function. Quantum confinement is responsible for the increase of energy difference between the energy state and band gap, a phenomenon tightly related with the optical and electronic property of the material. Means what? In this bottle, the different size nanoparticles can be taken. See here the size from the from left to right, the particle size of nanomaterial increases, and here the taken gold nanoparticles. When the material are this small, their electronic and optical property divide substantially from those of bulk material. That is, those nanoparticle having gold nanoparticle having small size, they show the quantum effect. That is, always and always the wavelength decrease, energy gap increases, wavelength decreases, and energy gap decreases, wavelength increases. Depending upon that particle size, it shows the quantum effect. That is, if we pass the light from this different size nanoparticle, it glow differently. See the color, red, yellow, red, black, white, etc. Due to this particle size, and it is nothing but the quantum effect. See this is the diagram. It is clearly in this diagram clearly shown that is compared the nanoparticle with the bulk material. See, these are the energy band gap between the two particles. As the energy gap is higher, wavelength is shorter, and if energy gap is smaller, energy gap is higher, wavelength is shorter, and energy gap is smaller, wavelength is larger. So the shift is depend upon always and always the particle size. This quantum nanomaterial energy between the valence band and conduction band is larger, that's why wavelength is shorter. That's why here delta E nano is greater than delta E bulk, and in bulk material energy is always and always smaller, that's why wavelength is shorter. So due to this, the smaller energy gap and higher wavelength, it shows the quantum effect, that it show the different colored light if we pass the light from nanoparticles. So the next topic is classification, that is classification of nanomaterial based on the dimension. Nanomaterial are as those which have structured component, that is with at least one dimension less than 100 nanometer. Means we already studied the definition of nanomaterial, that is those material having at least one dimension is less than 100 nanometer. So depending upon the particle dimensions, it having the different types. First type of nanomaterial is a zero dimensional nanomaterial. In such a type of nanomaterial, all three dimensions in a nanoscale, that is no dimension are larger than 100 nanometer. All three dimension below 100 nanometer, that is in nanoscale, and the most common example of zero dimensional nanomaterial is a quantum dots. These are the tiny particles of a semiconductor material. In last part of unit, we will study the quantum dots. Second type of nanomaterial is one dimensional nanomaterial. In this type of nanomaterial, two dimensions in nanoscale, that is one dimension is extended, means above 100 nanometer, and the common example is nanowire, nanotubes, and nanofibers. Third type of nanomaterial is a two-dimensional nanomaterial. One dimension in nanoscale, that is below 100 nanometer, and two dimension are extended, that is above 100 nanometer. For example, film, thin films, surface coating, computer chips, and most common example is graphene. And the last type is three-dimensional nanomaterial. No any one dimension in a nanoscale, all the dimensions beyond nanoscale. For example, fullerene. Then see, this is the diagram where all examples are there for all types of nanomaterial. These are the particles, pair, clusters, that is zero dimensional. All the three dimension within a nanoscale, these are the fibers, wires, or rod. One dimension beyond nanoscale, and two dimension within a nanoscale. Two dimension in this, one dimension in nanoscale and two dimension beyond nanoscale. And this is a bulk nanomaterial. We say 3D nanomaterial is nothing but the bulk nanomaterial. All the three dimension beyond nanoscale, that is a greater than 100 nanometer. So in this today's session, we will learn what is nanomaterial, properties of nanomaterial, and the types of nanomaterial.